rolling.
Okay, so only do the ones that are circled. So on 71, they put these directions like at the end, and that's why I circled it and then say, hey, pay attention to this. So you're going to figure out which reactions occur, and then the ones that do occur, write the balanced equation, calculate E naught, delta G naught, and K. Okay, so you're going to have to do a whole bunch of things, including the balanced equations. So let me give you a hint on 71. 2 reactions will occur, and 2 of them won't occur. Okay? Now, when you get to 71D, let me give you a hint. That's one of those that will occur. So you're exposed to air, so what's going to happen?
Oxygen.
It's going to, the whole key to that is going to be its oxygen. So you have FeSO4. So what form is the Fe going to be in? Aqueous. It's going to be Fe 2 plus. Let me give you a hint. Don't worry about the sulfate. The sulfate isn't going to be involved in this. Okay? So it's just going to be Fe2 plus reacting with the oxygen. It's going to be in a acidified solution. So in 71, you will have 2 that occur and 2 that don't. The 2 that don't, you just put no reaction. You don't have to do anything with it. But the reactions that do occur, lay this out when you answer this. Show me the reaction, and then I want the E naught, then I want the delta G, and then I want the value of K. So you're just going to stack those answers. Go boom, 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 boom. Okay? But make sure that over here I can see where the work goes. Don't have like your value of delta G up here and the calculation for delta G down here. So keep these going down and keep them like parallel so I can, here's my calculation of delta G, there's my answer for delta G.
Can we get the K equation again? It's not in front of it.
10 to the E naught times N divided by 0.0592.
Yeah, K is going to equal E naught to the N divided by
Wrote
0.0592.
this down because he told us not to. Told us to not remember.
Well, no, I said I'd give it to you. That okay. Anyway.
But
Now,
I don't have to remember.
When you get to 75, okay, you want to calculate KSP. Think this through. On 75, when you get done with your K value, do you want the K value to be a really big number or a really small number? Small number. So let me give you a hint. You want to arrange those equations on 75, because on 75, notice you have 2 reduction reactions. You're going to flip one of them and make it an oxidation. But remember, you're talking about the solubility product of cadmium sulfide. Cadmium sulfide is horribly insoluble. So on 75, think this through. 75, you want a non-spontaneous reaction. So you want to pick and flip one of those so that you end up with a negative E naught value so that you end up with a small value of K. Okay? You're not looking for a spontaneous reaction, you're looking for a non-spontaneous reaction. So when you get down to, then you also have to do, out of your book on page 897, 20.91 and 20.92. Those are those numbers that are written up at the top. Okay? So you've got the ones that are circled. Now, when you get to 83, okay, when you get to 83, let me give you a hint on 83. You want to find this identity of this metal. So what you're going to have to find is the molar mass of the metal. And then you're going to compare that to the periodic table. But let me give you a hint on 83. Remember that molar mass is grams per mole. Okay, that's going to be your whole key on 83. So you're told that you're going to deposit 1.141 grams. So you're going to have 1.41 grams. If you can figure out how many moles of the metal that you produce from the stoich, take the grams, divide it by the moles, there's the molar mass, look at the periodic table, that's how you're going to find it. So if all goes well on 83, the identity of that metal is going to end in IUM.
Chromium.
No.
Okay. Cadmium. No, that's CD2 plus. This is
It ends in
No, it's gotta
IU.
have a
It
three
needs to be a
plus.
plus.
Aluminum. I bet it's an
Aluminium.
I don't know. All I want to tell you is that it ends in IUM. Okay, shut down
And it's
your
not
camera. We're done.